Welcome to the third part, which I will talk a bit about the fake or simulated collision wall that I made. So in our tool that we have now, I, for example, here spawned a random zig line of lines. And I do want to find a way to snap these points a bit better. So they're now maybe a bit too random. So what I tried to do is I generate like a sort of like a wall around the curve. So based on this shape you draw, I will try to find some wall to snap to. And maybe to preview this better, maybe we can also make our curve a bit more complicated. So I will here click on the point and I can now continue to further here enhance the curve like so, just so it's a bit bigger than a simple zigzag. So it's a bit like so. From the convert actually, we will then do a resample. And we will try to calculate the middle line. So here we will try to find the middle ground here between all this curve data. And to do that, we will use here our segments, set this to 2. So we have now a point in the middle. We will also use a attribute called the curve view attribute. And the curve view attributes, the good thing about this is it will create a 0 to 1 range for each of these points. So for each point created on a segment, it will create a 0 to 1 range, as you can see here. So the 0.5 values are always the points that are here in the middle. And that's what we want to extract. So we can do a blast node where we can say that at or curve u, if for example it's equal to 0.5, we need to set this to points. And we need to inverse this. We now have these points here. So this is like the middle point, and we do want to connect them together. And we can just simply use an add node, go to polygon and go to group, and now to just simply fuse them based on the point numbers. So, but usually this is fine and will work. What sometimes can happen is I would sometimes place a poly pad, and this will make sure the points or the primitives are converted into one nice consistent geometry. So you can see that we've now created sort of like this middle reference, the middle line reference here. And to enhance the shape, we can always do a resample. So resample line, we can switch this to subdivision mode. So it's a bit smoother here in that area. We might want to increase here the length because we don't need that much detail. Maybe I'm going to go with 0.7 and see how far this goes, because we don't necessarily need all the fine detail. We just need a rough version or collision version to raycast against in a moment. And another thing that I would like to do is extract also the first and the last point, and this can be done by the group range node. So here group range, set this to points and the first and last point, and now invert this. We're now extracting that. We probably want to give this a better name called curve ends. So we can always use this group. With these points now, these endpoints, I want to move them in the direction that is sort of like where they currently are. So I want to extend the shape here because we need a bit more shape or space. So when I spawn all these lines here, you can see that I need to basically extend a little bit further because we have gone outside this range basically. And the way I will do that is I will calculate a vector in that direction. And I will use a wrangle here again to do that. And the wrangle only needs to run over the end points data. And we will now get our closest point. So point dot neighbor, or the neighbor point. So from itself, based on the current point number and 0. So what this means that if I'm currently at point 0, I will get a neighbor, which will be 0.1. And from here, I can calculate a look at distance and basically inverse it. So I want 0.0 to be looking at 0.1 and then inverse that normal or vector and then have that vector pointing out that way. So that way I can nicely move that curve. So we can set a normal value. We can use our look at function, and we're going to say from our current position, which will be from 0, look at your neighbor, which will be we need to extract the position, which will be point dot zero extract position, and the point we would like to extract the data from is the point that we have here, so our neighbor point. Once we have that, we have our data from the lookat, but we still need to multiply it by a vector. So here we're going to multiply it by 0, 0, 1, and this will automatically already give you the result. So if I enable here my vector, you can see now it points up to that way. Also from the bottom side, you can see it points in those directions. So this is one way of doing that. So just getting the neighbor and then using the lookat to then figure out the direction. We will then use a peak node to move along the normal. So we don't need to recompute normals, and we do want to here use the curve ends, and we can here move that without disturbing the other shape. So we're only moving those 2 points. And then from here, I will do another resample basically, and use the subdivision. So now we have a nice curve for the middle. So the only thing that I would like to do with this curve now is I would like to sort of like copy paste this or deform this on the left side and one for the right side. And that way I roughly have like 2 sort of like wall shapes. So this is the base data that we have, and now we need to understand how to move it to the left or the right. The way I will do that is by calculating some distance value. And we want to use a range node here now, so range group. And we're going to grab it from the convert line here. And with that, we will now here set this to points, and we will only now change here the offset to 2. So now we only have the points here on the left side. And if I invert the group, I will then have the points on the right side. So we can just simply do, for example, a split node here as well, where we can just say split on that group. So here we have the points on both sides, basically. I will do an add node for each of them, but maybe I'll just figure out one side and then I copy paste logic to the other side. We do want to here connect them as well, so they are connected in one line. This will be the reference line, for example. And then what we can do with this is we can calculate the distance from this line to our target line here. So we can calculate the distance. So we can put some wrangle here, and we can plug it like this. And we're going to say like get a distance. And we want to do the same thing we did a little bit before, is we want to get the nearest point from our current data, which is this one, to our middle reference data. So we want to get the closest point, and we want to measure the distance from that closest point to each other. So integer dot point number, so get nearest point. This will be from 1, so our second data, or the middle curve, and at position of itself. And this will now get the closest point. Now, once we have the closest point, we can calculate something which is called then the distance. We can use the distance function. And here we can say at position, and compare that to the nearest point, which is here points. So 1 dot position data dot point, and close it off like this. Oh, got one more element here. And now we here have a distance for each point. So each point on this curve measured basically the distance to that curve. So we have now a measurement on how far everything needs to move. So to continue, we will definitely keep working actually with the middle curve, because this is a more clean data. And we can actually just do an attribute transfer and transfer over the distance data. So here attribute transfer, and we're going to here transfer over the distance. So in here, I'm going to disable primitives and only say distance needs to be transferred. And under conditions, maybe going to remove here the threshold, and let's see how far we can get with this in a moment. So now I understand that each point has now a distance value, but we don't know yet where to move into what direction. And we can calculate the direction by orientation along curve. And here we can calculate that now. I will enable my vectors so I can see the rotations. I will now here go into a up vector of y-axis, and I will here open additional rotations and enable the jaw. And you can see we can now rotate where we want it to be going. So in our case, I probably want to set this to 90 degrees. I meant actually minus 90 degrees. So we want to move this in the direction of the original target here. So we know the distance, we know the direction. Now it basically gets combined by, again, another wrangle. We basically say that at our position, we're going to basically add an additional value based on the normal multiplied by our distance we calculated. And let's see what that gives us. So you can see that now we are going from our middle line. So if I show our middle line, so we are moving the middle line up to our target line where it roughly needs to be. Now you can still see that it's not perfect, and part of this reason why it gives us this result is because of this, basically here, the attribute transfer. So you can see that it gives us, based on the transferring data, some issues. To simply have around this is a smoothing. So I'm just going to smooth it out. Probably want to increase the smoothing to a higher value. So let's see how high this goes. 50 sounds good. And maybe we can have the filter quality below it. So you can see it has less of these harsh jumps. Then what is still left to do is make a fake wall out of this by just using a poly extrude. I will use poly extrude. And in here, what I will do is go into custom transform. And I'm just going to move this up like so. So I probably want to move this up by, let's say, 5 units. And now we have our wall. And the only thing left now is to repeat the same logic for the other side. Just copy paste this whole system on the other side. Everything is almost the same. So most of it will be the same. We need to make sure that we are switching this line. So we're having the other side. And we're also here changing the rotation calculation to plus 90 degrees. And that should give us the other side. And we can merge these two together. So you can see now we created this in-between wall for my curve. So I can probably need to move this down. So I would just place transform and move this down by, let's say, -2 units. And we can now use this, for example, in our beginning here. So let's make some more room. And we can do a raycast here from these points on the wall now. And we can use, or we can set the raycast to work with the minimum distance. And as you can see now, we are snapping here a bit more better. So all the points are roughly more controlled around that area. So it's a bit less random and a bit more controlled in those areas. And we could basically then overwrite this like this. So if I now would view my result, you can see that they're a bit more nicer aligned, and I can quickly turn it on and off. I again can play around with here. This is the noising of it, so we can here maybe change the noises now more because we're now raycasting that, so we can here play around a bit more how noisy it should be. Like for example this. Now what I did as well as a last finishing touch is also here this model here could also be targeted to the wall to make it better as well. The way they've done it is by using the split node again. So if I split based on the value called main. So I did made a group before here called main, which is referencing to this shape. And this is the exact shape that I want to extract. So I want to here use this shape and then raycast it against the wall. I do want to have a group where we specify to only raycast the ends. So here we're gonna get, for example, the edges. But I do actually want to use it as points because the raycasting node works with points. And we here want to use here the unshared edge data. And then from here, we can then use the raycast. And with this raycast, we will now use that data from here. So we can use here this data inside of this node. And we of course need to specify, it will be very messy now, we need to specify that edge part, and it might still be weird. And part of the reason for that is we need to switch the mode to minimum distance again, and now we have something like that. And you can see now we are snapping nicely here to the wall. There is one more little thing is, if you look closely, we're also here, since I cut open the shape, this is still a open area. So ideally when I here open to shape here, I need to select this and then here do a polyfill to actually close that shape. I might set this to triangles. And on top of that, the group main that we created here also needs to be selected on that new polygon. So I will need to add this to the group main, and we can use here probably the output here called batch. And I think I could just say here, add batch to that group. We can probably do a union with existing group. So we have something like that. So that looks a bit better. And let's see what it gives us here now as well. And now that issue is fixed. So after this, you can still do like some smoothing just to blend things a bit better together. And then basically we can merge our elements here like so. And now, as you can see, you can turn this on or off if you don't want this. But basically we're now forcing this to have like more nicer shapes. And this way we can, as artists, control a bit better how to blend this or to snap to rocks roughly. We can also try to get collision from Unreal, but this will definitely be faster in most cases. And then after that, we can still do the voxel. And then we have our final shapes and forms. So that was it for this video, and hope you enjoyed it.